Box and whisker graphs summarize the distribution of values. The box contains 50% of the values, and the whiskers, which extend to the top and the bottom, contain 100% of the values. The median is drawn as a straight line through the box. Half the values are below the median, and half the values are above the median. Box and whiskers graphs were added in Stella version 3.7, and I'm going to demonstrate how you can put them in your graph and what they mean. There are two different interpretations of the box and whisker diagram. One is across runs, and one is across array elements. I'm going to start with the one that works across runs, and here I have a sensitivity set up. I've got a couple input parameters into that sensitivity, and I can click srun and run the sensitivity. Now I'm going to add a new graph. And for type, I'm going to choose box and whiskers. Then I will add a variable to that graph, and I'm going to use a placeholder in this case. So the one in this model, financial results. That would give me a single value, but I want them at a number of different times, so I will put in some different times for us to see the values. And now we see the values from 2024 to 2044. Because I've selected a single variable as the input, the values are being displayed across the runs in the sensitivity run that was made. Unlike a confidence graph, I can actually add in a second variable into this graph. Say I wanted to put cash flow in here, and then I could see what's happening to EBIT versus cash flow across these different times and the sensitivity run. Alternatively, it's possible to look at values across array elements, and this model is set up as the same as the model we were just looking at, except it has an additional array element called run with 100 runs, which allow us to simulate 100 different runs in parallel. Each of those runs is set up essentially the same as the sensitivity run was set up in the previous example. In this case, I'll again select a placeholder, and I'm going to ask for the placeholder across star. Now what we're seeing is for a single run, what is the distribution of values across all the elements of star, where star in this case is just run, so there are 100 different elements. Again, I set it up to run at different times, and we can see that we get roughly the same results. This model may not be completely identical to the one before, as we got with the single model looking at just one element. Unlike the setup over a sensitivity run, though, in this case, it's possible to actually make this a comparative graph, and we can make multiple runs. For example, suppose that I take away all the CapEx, so I'm not investing anything in capital, and develop lots and lots of R&D work, and then run that scenario. As I run that scenario, the new values come in, and we can see the consequences of that are a reduction in revenue, and if we were to look at EBIT, we see EBIT actually goes negative. Clearly, this is not a very good strategy for making more money in the long run. These two models are available as with a link from this video, and there's also a paper that kind of documents the process for creating these types of models and arraying these models. That's available with a link in the documentation.